So suppose you've worked with your model and you get down to this modeling high tide and you need to figure out the phase shift. So the question is, well, how do I do that? High tide occurs at 0.45 hours. So, okay, that's your X value. The maximum height of 5.96, that's your Y value. So let's put all that stuff in. It's going to be 5.96 equals 2.95 sine of 0.505 times 0.45 minus phi plus 3.015. So let's see if we can't solve here for X. So the first thing I would do is I would subtract 3.015 from both sides. Now, I'm a little disappointed here. Let's take a look at what number we get there. Let's see, graphing calculator, 5.96 minus 3.015 gives me 2.945. So 2.945. I'm pretty sure that this is supposed to be 2.95 is really the number that they were trying to get here. 505, 9.45 minus phi, like that. So I'm going to assume this is actually supposed to be 2.95 here. I know that looks bad. It's like, well, why are you doing that? Why are you getting that? It's because eventually I'm going to get a 1 on the right-hand side. Now let's do 0.505 times 0.45. And I get 0.22725. I'm just going to write down that whole thing, 0.22725 minus phi. Now my goal is to solve for phi. So, okay, let's take a look here. I've got 2.95 on both sides. So if I divide both sides by 2.95, on the right-hand side, that's going to be a 1, so that'll disappear. On the left-hand side, that's going to be a 1. So I'm going to get 1 equals the sine of 2.2725 minus phi. Here's where you can use your inverse sine. If I wanted to get rid of the sine here and get my hands on what I have on the right-hand side, then I can take the inverse sine on both sides. So the inverse sine of 1 and the inverse sine of the sine of 0.22725 minus phi, like that. Now that's pretty nice because of two things. On the left-hand side, inverse sine of 1, this is the angle whose sine is 1. So where does that occur? Well, it has to be between negative pi over 2 and pi over 2, and it turns out to be pi over 2. That's where the sine is at its maximum, is at pi over 2. What's going to happen on the right-hand side? Sine inverse and sine cancel each other out, so I get 0.22725 minus phi equals pi over 2. And then to finish this up, if I move the phi to the other side, it becomes positive. Move the pi over 2 to that other side, it becomes negative. So now to get phi, all I need to do is come up with a numerical value for phi like that. So let's clear out a bunch of old stuff and type in 0.22725 minus pi over 2. So negative 1.31435, etc. All right. Does that help? That's
yeah, I think so. I think I
kind of nice because does touch on the stuff that we covered today too.
Wait, so it's not really negative though, or?
Well, if you put it back into this function, you're subtracting a negative, it'd be like adding then, right? So it'd be this plus point or 1.35, yeah, 1.34 or 35, or however many digits you need there. So yeah, the overall function would be y equals 2.95 sine of 0.505x or plus 1.3435 plus 3.015. Yeah. Now, if you're comparing this to what we did in class and we solved things, the way I set these things up is y equals a sine bx plus c plus d. The book uses a minus here. That's okay. You know, so if I would have solved it my way, I wouldn't have ended up with a negative here. I would have just ended up with positive 1.3435. That's okay, because they started out with a negative, that's why you get this negative here. But in the end, when you put it back in the formula, we'll both end up with a positive value there. So it's whatever form of this you like. You want to use the minus, you want to use a plus.
Yeah,
Doesn't make any difference.
I think I maybe like wasn't taking into account like the height of it. I don't know.
Okay.
I think I understand now.
All right. Good. Good deal.